In this video, we'll dive deep and understand the data structure called lists. Of course, we know a little bit about lists from our previous videos, but we'll dive deep in this section, understand a lot of operations on lists, and we'll dive deep into the specific data structure, only the specific data structure of lists in this video. Now, let's go and understand some of the high-level details of what a list is. A list is a sequence data structure, which means it stores items in a sequence. It is often used to store collection of items, strings, integers, or you can also store lists of lists. We'll see some of those examples. Lists are often enclosed in square brackets, as you already know. So lists are, we use square brackets to create a list, okay? And lists have, so items in a list have an index value, which means they're indexable. Lists are indexable. Items in a list are separated by a comma, and lists are mutable. This is a very, very important property. Mutability means that items in a list can be changed. This is a very, very important property. There are some data structures which are non-indexable and which are non-mutable. We'll see those data structures when we learn other data structures in detail. But remember, lists are indexable and mutable. That's a very, very important property of a list. Now, without further delay, let's go through some code instead of theory. That always helps us get a good sense of what's happening. Okay, so let's understand how to create a list. So you can create an empty list by just putting two square brackets like this. If you just put two square brackets, it means it's an empty list. Okay, now I can add, so this is one way to create an empty list. The other way to create list is to explicitly list out the items in the list, right? So this is a list of strings, okay, with four items in this list, which are strings 1, 2, 3, and 4. Similarly, I can create a list of integers here, right? This is a list of integers 1, 2, 3, 4. I can create a list of lists here. Remember, this is one list. This is another list here. And this list, this bigger list here, this bigger list contains two lists. Okay, so this is a list of lists where the first element is this list of items 1 and 2. And this is the second list. So it's a list of lists. Okay, you can also have lists with different data types. Here, this is integer, this is string, this is integer, and this is a float, right? So you can have lists of all different types like this, right? So this is how you create lists, by explicitly calling out or listing out the elements of the list itself, or by creating an empty list. Having said that, now let's go and understand a few important operations on lists. Okay, so for example, if I want to know the length of a list, suppose I have a list like this. If I want to print the length of the list, the keyword is len. Okay, so sorry, len is not a keyword, I'm sorry. Len is basically a function that we have. Okay, len is a function that operates on lists that will give us a result of 4. Okay, so now if you want to append something to a list, if you want to add an item to a list, right, how do you do it? It's very simple. You say, suppose my list is these 4 strings, 1, 2, 3, and 4. You just append 5 to it. And if you print the list, you get the 5th element at the end. Okay, so append always adds items at the end of the list, as this simple syntax shows. Now let's understand other ways of adding items to a list. Okay, you can insert an item into a list. For example, if I have a list with 3 items here, remember it is 1, 2, there is no 3 here, remember, there is only 4 here. Now, if I give it if I call the list insert function, list.insert, right? So lst is basically the variable name. Remember that it's not list, it's lst. If I say list.insert and the element that I want to insert is 3, this is the element that I want to insert, and I want to insert it at location 2. This is the location. So this is location 0, this is location 1, this is location 2. And now what I want to do is I want to insert this 3 at location 2, right? So what happens eventually is 4 will get pushed to the right and 3 will get put in between 2 and 4. Okay, so the final list will be 1, 2. Since your string 3 got put in front of 4, it will come here and then you'll get your 4. Okay, so this is how list insert works. It has 2 elements. It has the location and it has the element that you want to insert. Okay, and this is how it works. I recommend you play around with this a little, try various options to see what happens exactly. Always, for all the code that I'm listing out here, you get IPython notebooks anyway. Please play with the code to understand how it works, where things break down, how to actually change. Don't just copy paste this. Always play around with this. Change it a little bit here and there. Okay. So imagine if I have, if I want to remove an item from a list. Okay. So let's see how do I do it. Suppose I have a list here where I have 1, 2, 3, 4, and again I have a 2 at the end. So 2 is repeating twice. Okay. If I say list.remove 2 TWO, it not typically, it always removes the first occurrence of this element. Okay, so this is an element, right? It only removes the first occurrence, not all the occurrences. So after I remove 2, if I print the list, I get 1, 2, 4, and 2, which means only this 2 which was here, that 2 which was there got removed. The last 2 is still there. That's important. So list.remove only removes the first occurrence of the element that you have asked it to remove. That's important to understand. Okay. Now let's understand two other very important commands called append and extend. Very simple commands, very straightforward, nothing very fancy here. Okay. So let's assume I have a list, lst, which is 1, 2, 3, and 4. Imagine I have another list called lst2, which is 5 and 6. If I say list.append lst2, what happens? That's important, right? So when you use the function append here, what it does is it appends the list to. So remember, it appended. So this is your big list, right? This is your big list in these square brackets. So this is your big list. Let me put it there for you. Okay. So it took this list lst2 and appended it at the end. Okay. So you have a list within a list. Okay. So it appended the list 2 at the end of list lst. Okay. So this is again a list here. Don't forget that. So it appended list 2 at the end of elements of list 1. Okay. On the other hand, oftentimes you might want to use the function extend. Okay. Let's see what extend does. So if I have a list 1, 2, 3, 4, and if I have list 2, 5, and 6, if I say list.extend list 2, it adds these two items at the end. It adds these two items as elements, not as a list, at the end of my list. So my final outcome here will be 1, 2, 3, 4. My 5 and 6 are not added as a list. They are added as elements. So my 5 and 6. So extend is something that you'll use a lot. Append, seldom used. But of course, everything has its own use applications. It doesn't mean that we don't use. In data science, we typically use extend much more than append. Okay, having said that, how do you delete items in a list? There are two functions through which you can do it. So imagine if I have a list like this, 1, 2, 3, 4, 5. These are the 5 elements of my list. If I say del list 1, this is item 0, this is item, these are the indexes, right? 2, 3, and 4. These are the positions or the indices or the indexes. Okay, so I'm saying delete list 1, which means it will delete this item. And when I print it, what does it return? It returns 1, 3, 4, and 5. So the 2 has been deleted. Okay. Now I can also use another function called pop. Okay. So remember, when I delete an item in the list, it doesn't return anything much to me. When I say pop, I can get the item that it returned and put it in a variable called a. This is what typically pop is used for. Okay. Delete basically means it removes this item from the list, while pop actually returns the item that it removed. So when I say, so what is my list right now? My list right now is 1, 3, 4, 5. So this is index 0, index 1, index 2, and index 3. Now when I say list pop 1, and if I store that value, what is 1? It is 3. At index 1, you have the string 3 stored here, right? So that is stored in variable a. When I print a here, I get my 3. Okay, when I print my list now, this is removed, right? So you have 1, 4, and 5 left as your final list. So you can either remove items from a list using del or using pop. There are two ways of doing it. Okay, having said that, let's move down and see. Okay, there is another way to remove. So here, if you recall, in both these cases, we give the index of the item that we want to remove. I can actually give the exact element that I want to remove also. Imagine if I have a list which is 1, 2, 3, 4. If I say lst.remove 3, okay, if this is what I say, it tries to find this item 3 here and it will remove that item for me. Okay, 1, 2, and 4. Right? Very, very simple. Nothing very fancy here. Just removes that item for me. Now, there are some keywords in Python. There are some keywords, okay, which are reserved words in Python that are meant for operations on lists. The two keywords are in. So actually, in is the primary keyword. Okay, let's understand. Imagine if I have list as 1, 2, 3, 4 strings. If 2 in list, so this in basically says, does this element 2 or the string 2 exist in list? Okay, if it exists, print AI, and it prints AI. So in basically says whether this element, if you say element in list, okay, if you say this, what it does is it checks whether this element is in this list. If it is, it returns true, or else it returns false. Just the way, I mean, of course, I can concatenate this in with not. I can combine it with not. Not is basically a keyword which says negation operator, right? So if I say, if 6 not in list, of course 6 is not in the list, okay, print ml. So it prints ml here. So in is a keyword which is very useful for list operations to check whether an element is present in a list or not, right? So now let's go on and understand some other functions. So list reverse, okay, very simple operation. So if I have a list which is 1, 2, 3, and 4, if I just say list.reverse, you get 4, 3, 2, 1. Very simple function here. Next comes list sorting. See, all these functions are used in some place or other in your Python experience and data science, etc. Right? And that's why you might say, okay, why are we just listing all the functions and giving an example? Because we'll reuse them. Please bear with me. We'll come back and reuse all of them through this course. And these are fundamental functions that we'll use extensively throughout this course. Okay. So, okay, let's see what list. Let's go through some examples instead of the theory part. Okay, that makes life simple. Okay, suppose if I have these numbers 3, 1, 6, 2, 8, and if I say sorted, I can call the function sorted here. So it returns this same list sorted. Okay, now if I print sorted list, I get exactly sorted, and this is sorted in ascending order, and my original list stays the same. Okay, my sorted list is the list of numbers which is sorted, right? My original list stays the same, it doesn't change. Only whatever it returns is the sorted list, right? Now comes an interesting thing. If I want to sort it in ascending order instead of descending order, what can I do? I can do very simple. I can call the function sorted on the variable, on the list numbers, and if I just say reverse equals to true. Okay, so what is my original list? 3, 1, 6, 2, 8. So I'm just sorting, I'm calling the function sorted on the list, on this list, right, with reverse equals to true. Then what I get here is 8, 6, 3, 2, 1 in descending order. In descending order, right? So this is what, if you want to sort in ascending order, just call sorted. If you want to sort it in descending order, you can use the reverse equals to true parameter for this function. Okay, so now let's go down a little bit. Now, okay, if I want a case where, imagine if I have a list like this, okay, I can sort the list and put it back in the same list. Okay, so my list here is 1, 20, 5, 5, and 4.2. Okay, now if I say lst.sort function, it's not sorted, remember, this is sort. Okay, if I do this, it will sort my list and put it back in the list. Okay, so if I print lst after calling this sort function, it's in a listed order. Sorry, it's in a sorted order, not listed order. Sorry, it's in a sorted order in increasing order or ascending order. Okay, now you might say, okay, see, remember here I've compared a float to a int. Okay, for those of you who are coming from C or Java background, right? Now the question is, what happens when I give, suppose if I have a list like this with 120, this is a character B, this is a character A. Okay, this is basically thought of like a string. Okay, and 5. When I say list.sort, what happens? It gives you something called a type error. It says less than is not supported between instances of string and int. How can you sort? You can only sort if you can compare them, right? If you have to compare them, the operation less than, greater than, and equal to should be supported. If it's not supported, can you say that B is less than 1? It's absurd, right? It makes no sense at all. It's basically it makes no sense at all, right? Since you cannot compare a string, with an int, or with any numerical value, it says this operator is not supported, and hence it's a type error. It will not be able to sort these lists. Okay, having learned that, let's go down. Okay, this is a small thing about references of lists. So if I have a list like this, and if I say ABC equals to list, what happens here is ABC literally points to the same memory location. So imagine what happens in this. Okay, you have in the memory, you have a list stored like this. This is in the memory. The moment you say ABC, and of course the variable list points to 1, 2, 3, 4, 5. When you say ABC equals to list, ABC also points to the same thing. Now when you say abc.append 6, what happens? I'm going to add 6 to this. Now when I say print list, what happens now? It will print the element, it will print the list which has 6 also here. So these are called references, or for those of you who are coming from C, these are called pointers, right? By default, in this case, both list and ABC are pointers. So if you change ABC, this is not a deep copy. I'm not creating an other memory location with 1, 2, 3, 4, 5 when I do this. Okay, I'm just creating a variable called ABC, which is pointing to the same memory location as my list. Okay, so this is what is happening internally in memory. So these are basically two references. This is the reference 1, and this is reference 2 to the same memory location. So any edits you do with ABC will be reflected in your LST. Okay, so let's go down now. Okay, suppose if I have a string. Okay, suppose if I have a string S, the string looks like this. It is basically a string which is separated by commas. Okay, 1 comma 2 comma 3 comma 4 comma 5. Now I can use the split function in a string. Okay, if I say S list equals to S dot split by comma. So I'm saying split this sentence or string using a comma. Now when I split it, what it returns me is basically a list. And if I print this S list, it returns me each of these words which are separated by comma without the comma. This is my first element, this is my second element, third element, fourth element, and fifth element. Or if you want to call it 0, 1, 2, 3, 4. So string.split is a very, very good technique, or a very, very good function to split a given sentence into, oh, there is a better example actually. Let me show that. So imagine if I have a string S, which is this is applied AI course. See, remember, all these are separated by spaces. This is a space, this is a space, this is a space, and this is a space, right? Now what happens if I say s.split without giving any input here? The default split character is a white character, and a white character basically means a space or a tab. So the moment I say s.split, okay, and if I print this, so what it returns me is a list. When I print that list, I basically get each of the words. So if you have a sentence, and if you want to get each of the words in that sentence, string.split is the function to use. Okay, and it returns lists. Now let's go and understand a little bit about indexing in a list. Okay, so okay, let's go down here. So if I have a list 1, 2, 3, 4, if I print list 1, okay, this is index 1, index 0, index 2, and index 3. What is list 1? It prints 2. Now let's go and understand a little more. So let me write some more code here, a little bit of code. Okay, nothing very fancy. So if I say print lst -1, what happens? Okay, let's just run this. So -1 basically, so I can use negative indices. -1 basically means this element. Okay, -1 basically means start from the end. See, your 0, 1, 2, 3 starts from the start. Okay, and goes in this direction. -1 starts at the end of your list and goes backwards. Okay, now let's see what happens if I do string list -2. Sorry, if I say -2 and if I enter, I get my value of 3. Right? So this is -1, this is -2, this is -3, and this is -4. So I can index a list either using positive numbers going in the forward direction from start to end, or I can use negative numbers by starting from the end. See, sometimes it's impossible to pick the last element in a list or the second last element in the list. How do we do it? One way to do it is to use negative numbers as indices. Okay, so this is a simple, nice hack in Python, which is very useful actually in the real world. Now let's learn about slicing. Slicing is again very, very simple. Slicing basically means, okay, let's go through examples. That's actually much better. So imagine if I have a list of numbers 10, 20, 30, 40, 50, 60, 70, 80. If I want to print all the numbers, I can just say print numbers, or I can use this notation. This column says that print from start to end. So when I print this, I get all of this. Now let's change it slightly. If I want to print all the numbers, so if this is 1, 2, 3, 4, 5, 6, 7. If I want to print just these 4 numbers, what can I say? So I can say print numbers. This is your start. This is your start and this is your end. I'm saying start at 0, which means print from the 0th element up to the 4th element. Okay, from index 0 up to index 4 without including index 4. So when I print this, I get 10, 20, 30, 40. Okay, so while indexing, you have two numbers. You have the start number and you have the end number. So the start index will be printed, end -1 will be printed. Okay, I recommend you play around with these two numbers, the start and the end indices. Sorry. Okay, now let's go down and see slightly more interesting ways of indexing numbers. Okay, so if I say print numbers, again I have the same 10, 20, so on and so forth. Now here you notice two columns, right? So these two columns are like this. I can print numbers. I can give it the start index, the end index, and the third one is called step size. Okay, so here, since I'm leaving this empty, it means from 0 up to the length of the whole list, and I'm saying the step size equals to 2. What does step size equals to 2? Which means it will take the first element, print it. It will skip the second element. It will take the third element and print it. It will skip the fourth element. It will take the fifth element. So every time it goes, it doesn't go to the next item. It takes a step of size 2. Okay, then it goes to 50. It skips, then it takes a step of size 2. It prints 70. Okay, now I can change it slightly like this. I can say my start equals to 2, my up to end. So if I leave it empty, it means go up to the end, go up to the ending. Okay, with step size 2. So what is my element? So this is 0, 1, 2, 3, 4, 5, 6, 7. So what is element 2? So start here, start at 30. Okay, go up to end, go up to 7 with a step size of 2. So I have printed 30. Now I'll take a step size of 2, which means I'll skip 40 and I'll go to 50. I'll print 50 here. Then again, take a step size of 2. I reach 70. So I have my 30, 50 and 70. If I take step size of 2, I don't have any other element, so I'll stop. Okay. So this is one way for you for indexing items in orders that you care about. Okay. Again, these things will come in extremely handy when you have to manipulate data. Okay, so the syntax is you have your start, you have your end, and you have your step size, right? These are the three numbers that you'll use when you're indexing a list. Okay, so there is another very important operator like an addition. Okay, so let's see what happens. So if you have a list 1, 2, 3, 4, okay, and if you have list 2, which is names of 4 of our teammates, including me, and now if I say my new list equals to list 1 plus list 2, this plus need not only be a numerical addition. When I do this, my final list that I get is basically an extended list where these two lists are combined using the extend function, if you recall, not the append, the extend function. And basically I get a bigger list with elements of all of the list one after other. And this plus operator can be applied on lists for extending, for adding elements basically. Okay, so this again is very, very handy. Now there's a very useful function, especially in data science, called a count. Okay, imagine if I have a list of numbers 1, 2, 3, 1, 3, 4, 2, 5. If I say numbers.count 1, okay, what it tells me is it prints what is the frequency of the element 1 in my whole list. Okay, what is frequency? Number of times that 1 occurs. 1 occurs here, 1 occurs here. So it prints me 2. Okay, can we do the same thing? Can we do the same thing with printing the frequency of let's say 3? Okay, so if I change this to 3 now, and if I execute this, I get 2, because 3 also occurs 2 times, right? Because if you look at it, 3 occurs here, and 3 occurs here. So count function is extremely useful in data science whenever you want to count how many times does an element occur in your list. It's extremely useful. We'll use this in computing histograms, PDFs. Again, if you don't know these concepts, don't worry. We'll learn them as we go. Okay. So count is a very, very useful function which tells you how many times an element occurs, in a list. Very, very useful function. The next important idea is how do you loop through elements in a list? Okay. So it's very, very interesting again here. These are used extensively throughout Python programming, especially in general and also in data science, because we use lists a lot to store data. So imagine if I have a list like this with elements 1, 2, 3, and 4. If I say for element in list, okay, so and if I say print element, okay, this is one very interesting way for you to iterate. So this is like looping through, right? This is basically a looping. But instead of looping using, I could have said between 0, 1, 2, 3. I could have said go from in the range of 0 to 4, right? Which means 0, 1, 2, 3, print the elements. But if you have a list, you can loop it using this very elegant strategy. Okay, if you say for element in list, it will pick each of the elements. It will pick 1 first, then it will pick 2, then it will pick 3, then it will pick 4. Print ELE. Okay, so it's going to print this. So if you want to loop through elements of a list, this is a very, very elegant way. It's very readable, remember, for each element in the list. This is like super easy way to read what's happening, right? The next very interesting idea is list comprehensions. List comprehensions, actually, frankly speaking, I have mixed opinion about it personally. Some people love it and some people don't like it much, but let's go through and understand what it is, okay? Suppose if I want to create a list of squares of numbers. So this is 0 square, 1 square, 2 square, 3 square, 4 square, etc. Okay, one way to create it is I create a list called squares. Okay, and I write a simple for loop for I equals to 0 to 9. That's what this means, right? Range 10 basically means from 0 to 9. Okay, squares dot append I 3 square, 3 power 2. So this is exponent function, right? So I power 2. This is basically nothing but this is I power 2. That's what it means, right? So when I say squares dot append I square, and I just print squares, right? So this is one way for me to, this is very traditional. This is what you'll see in many languages like C, C++, Java, etc. I mean, syntactically, it's very similar, right? Logically also. Now, what Python gives you is Python gives you an alternative way of doing the same thing using something called list comprehension. Elegant idea. It makes, so this whole code, which is almost like 1, 2, 3, 4 lines, can be written in just, like this whole 3 lines can be written in 1 line. These 3 lines here can be written in just 1 line. Okay, so this is an example of list comprehension. This is very, very elegant. So let's see. I can say create a list called squares. Okay, since I'm putting the brackets here, it knows that it's a list. Okay, where each item is basically I power 2 for I in this range. Okay, so what am I doing? I've taken, so let me change the colors here. I'm taking this, I'm putting it here. Okay, and I'm taking this part. I'm taking this part and I'm putting this part here. So in literally 1 line, by doing the operation that I want, see if the operation that you want to do is small. Okay, so here of course we are creating a new list called squares. Okay, let me erase some of this. So the syntax here is very, very straightforward. Each element in the squares is basically an I power 2. Okay, it's basically an I power 2 where I is in, for I in this range. Okay, so another way, mathematical way to write this is I square for I in the range 0 to 9. This is how mathematicians write it, right? So I square for all I that lies between 0 to 9, right? So the same thing can be written in computer program using this. So the way to read this mathematically is compute I square for all I that is in 0 to 9. Exactly the same one-liner that we write in mathematics, that we write in mathematical logic, we are able to now convert it here. Okay. Now the next question here is about the examples. Okay. There are more ways to create list comprehension. Let's go through some more examples here. Okay. So let's assume I have a list like this, minus 10, minus 20, 10, 20, and 50. If I create a new list, which is I into 2, okay, so let me go down a little, okay, so that I can show you all the examples here. Suppose if this is my list, and now I'm creating a new list, which is 2 into I for I in list. So what it will create, it will multiply each of these elements into 2 and put in the new list, and that's what your value is, right? I can also put more conditional statements here like this. If my new list is for I in list, if I is greater than equal to 0, which means in your new list, put items from list, okay, I for I in list if I is greater than 0, which means it will discard all these negative values and it will only put these positive values which are greater than equal to 0. So if I print my new list here, I get 10, 20, and 50. Very simple. There is a slightly complex way of doing it now. There is another interesting thing that you can do with list comprehensions. Okay, so let's look at this. If I create a new list, and my new list is basically a list of tuples here. These are tuples, right? We know what tuples are, right? Key value pairs, right? So I'm creating a list of tuples here where the first item in the range of 10. My first item is the number, second item is the number square. Okay, so let's see what happens when you print this. You get a list. This is a list. It's a list of tuples. Each element here is a tuple, where the first element is 0, 1, 2, so on and so forth. The second element are the squares. Yes, exactly, that's what is happening here. Okay, now there is a more complex list comprehension that we can learn, which is basically list comprehension for nested lists. Again, this is what we use extensively in data science because we operate on matrices and we operate on vectors. I can create a matrix like this. So let's write this matrix. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. This is my matrix. And I'm storing my matrix as a list of lists. So I'm creating this as a first element, second element, and third element. I'm creating a matrix here as a list of lists. Each of these is a list, right? And each list here is a row. This is my row 1, this is my row 2, and this is my row 3. So those of you, suppose if this matrix is M, there is something called a transpose of a matrix, which is often written as M power T, capital T. Transpose of a matrix basically means if this is your matrix, okay, these are called rows of a matrix, right? These are called rows of a matrix. And these are called columns of a matrix. Okay, these are called columns and these are called rows of a matrix. Now what I can do here is, if I swap rows and columns, so let me write the M transpose. M transpose is 1, 5, 9, 2, 6, 10, 3, 7, 11, 4, 8, 12. So basically I took each of these columns and made them into row. So this is my first column, which I made into first row. This is my second column, which I made into second row, and so on and so forth. That's what a transpose is. Now, in traditional programming languages, you can compute transpose of a matrix using code like this. Okay. So you're saying, since this has 4 columns, right? Column 1, this matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Since it has 4 columns, column 0, column 1, column 2. Okay. This is row 0, row 1, row 2. Right? So I can say, I want to create a transposed matrix of M, and I'm going through each of the columns. Okay. I'm going through each of the columns because I have 4 columns here, right? And for each of the columns, what I do is, I create an empty list here. Now what I'll do is, for each row in the matrix, for each row 0, row 1, row 2. So because my row is basically, because I've written my initial matrix as a list of lists, right? Where each list is a row. This is row 0, this is row 1, row 2, etc. Right? I'm taking the first element here. I'm taking the first element of each row, right? I'm taking the first element of each row and I'm putting it into LST, right? This is what I'm doing here. And now I append this list. See, remember, not extend, but append to the transposed matrix. Now, when I do it, at the end of it, this is the code that I get. What is this matrix? It is 1, 5, 9, 2, 6, 10, 3, 7, 11, 4, 8, 12. This is a very classical way of doing transpose of a matrix using lists. But the same thing can be done in literally one line using list comprehension. Okay, and see, this whole code that we wrote here can be written in literally one line. So transposed is a list, okay, of lists. So this is a list of lists, right? Where the inner list is take the ith element of each row for rows in the matrix, and your I itself lies in the range 0 to 4. Okay, literally in one line, this is using list comprehension, right? In one line, I have done what we have done exactly what we have done in these many, literally this whole for loop, this whole thing has been replaced by this single line here. While this is elegant, I have my reservations about it. See, this is very elegant, but the problem here is, of course, this is elegant, smooth, beautiful, etc. But for some people who are not very comfortable with Python, this decreases readability. This reduces or decreases readability. So it's for some people who come from Java or other backgrounds, trying to understand list comprehensions like this, especially complex list comprehensions, because this is a nested list, right? This is a list which has a list inside it, and it's slightly complicated. So list comprehension, while it's elegant and beautiful, sometimes it results in reducing readability of the code. For people who come from other programming languages, this will be like Greek and Latin. Of course, for those people who don't know Greek and Latin. Okay, so this will be a harder syntax to understand than this. This is very, very straightforward for people coming from any programming language. Okay, this is easy to read and understand. Okay, and this is harder to read, but it's concise. The advantage that this has is that it's very, very concise and elegant and beautiful. Okay, with this we end our video about lists. Of course, I've covered lot of properties and lot of functions and lots of operations that we can do in lists. I strongly recommend you play with this whole with this IPython notebook and dive deep and understand, change this. I've given you some examples. Please play around, try where things break, try to break things, or try to understand them deeper by playing around. And that's the exercise for you for this using this IPython notebook.